Hello, I'm Joshua Dukes, and welcome to Newton's Laws of Motion. Now, I'm going to be explaining the laws of motion that Isaac Newton discovered back in a time that I don't really care about. The first law is an object in motion will stay in motion unless acted upon by an external force, and vice versa. If an object is at rest, it will stay at rest unless acted upon by an external force. What this basically means is an object that's in motion or at rest will not have a change at all unless something's acting upon it. Like a car is on the road, it's been given gas, but it stops. Now, why does the car stop? Because friction is moving against the tires. Tires are going that way, friction's going that way. So the car eventually will stop. It's being acted upon by an external force. Now, let's say the car is stopped on a hill and it's in park. But take it out of park, just put it in neutral, it's going to start rolling backwards. Why does this happen? Because, again, it's being acted upon by an external force called gravity. Here's a little video showing a little example on what that means. Somebody should have stopped him. Something did. Welcome back. I hope you liked the video. Okay, now on to Isaac Newton's second law. The greater the mass, the greater the force needed to move it, or F equals ma. Now the equation is force equals mass times acceleration. Now, what is acceleration exactly? Now, acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. Now, its velocity is basically just the speed that it's going at. Let me give you a bit of an example. Let's say a biker is going 20 miles an hour. He's got some strong legs. And let's just say that he wants to change and make a stop. Now, to get the now he's going from 20 to 0. To get the acceleration of that, you need to take the change in the velocity and divide that by the time it took him to reach that change. Now let's say it took him about 2 seconds to change from 20 miles an hour to 0 miles an hour. His velocity, of course, would be 10 miles per second squared. Let me give you a little example of that law. The greater the mass, the greater the forces needed to move the object.
I can't do this.
Welcome back and on to Newton's third law. The law is every action has an equal and opposite reaction. What this basically means is that if, let's say, an object hits a wall, now the force that that object was traveling is going to hit the wall, and the wall is going to have the same force directed right back at the object. And the object is probably going to go backwards. Or let's say that two cars are coming down the road and they come into a head-on collision. What's going to happen is that either the cars are going to just push themselves apart from each other and they're both going to go back, or if one has a greater velocity, it's just going to push that other car backwards from whence it came. But it's going to be slower because the car's velocity, the weaker one, is going to cancel out a bit of the higher velocity. Here's a little example on how that works.
I'll go back.
Thank you for watching this video. All humor aside, these laws basically make up the universe. You can't have anything without having these laws, because otherwise you're in a cartoon. So thank you for watching, and I hope you enjoyed it. See ya.